Salam and welcome everyone. So today we're going to be working on the question on the screen that says calculate the change in enthalpy of reaction and the change in internal energy of reaction at 298 kelvins for the hydrogenation of ethine C2H2 to ethene C2H4. Ethine is an alkyne and ethene is an alkene. So we've also been given the equation that we're going to be working with, as well as the change in enthalpy of formation C2H2 gas. We've been given the value here. Actually, this particular question stops after the chemical equation. But in order for me to make this particular video easy, I decided to write out the change in enthalpy of formation for C2H2 gas, as well as the change in enthalpy of formation for C2H4 gas. So that is basically the information that I have thus far. So having this information is very key for you in an exam or in a quiz. They're going to give it to you, but in an assignment they expect you to go to the resource section of your book, or to go online and just google the standard formation of whatever molecule your teacher asks you in the question. So in this particular case, this is not hard. In order for us to go and solve this question, the first thing you have to do is to write out the formula. Change in enthalpy of reaction is equal to the sum. So I'm just going to write out this equation and I'm going to explain it to you. So for products, reactants. So just looking at the work, you're gonna observe that I wrote the exact same thing, and I wrote two of the exact same thing, right? The only difference is that the left side of the minus has products, the right side has reactant. So what this is telling you is that the change in enthalpy of reaction is equal to the sum of the change in enthalpy of formation for the product, okay, and then minus the sum for the change in enthalpy for of formation for the reactant. So I'm going to like basically write all of this information down. So the translation of this question in terms of this formula is just simply the change in enthalpy of reaction equals change in enthalpy of formation, okay, of the products, and our product here is just C2H4, which is ethene. So C2H4, okay, gas, okay, minus the sum of the enthalpy, so the sum of the change in enthalpy of formation for the reactant. So we're just going to say the change in enthalpy of formation for C2H2, because now we're dealing with reactants since we just had one product molecule, and then we have two reactant molecules. So we've done the one for ethene, and then that plus change in enthalpy of formation for the H2 gas molecule. As you can see, we have followed what the information here. So basically what we did here is that we translated whatever this information is up top, and we wrote it in terms of the question. So all you have to do is now substitute. So what you end up substituting is change in enthalpy of reaction is going to equal C2H4. We're just going to substitute whatever this is. So this is going to be 52.26 kilojoule per mole, okay, minus change in enthalpy of formation for C2H2 gas plus 226.73 kilojoule per mole, okay, plus 0. So that's basically it. Change in enthalpy of reaction becomes 52.26 kilojoule per mole minus 226.73 kilojoule per mole. So that's basically the question, right? So change in enthalpy of reaction ends up becoming 52.26 minus 226.73 becomes negative 174.47 kilojoule per mole. So this is basically the answer to the question. And as you can see, our question was given to us in two decimal places for both the change in enthalpy of formation for both ethene and ethine. So we can just feel comfortable that this is written in the answer is written in the correct format in two decimal places. So now we found this information, and the question actually just does not ask us for just change in enthalpy of reaction. A question also asks us for the change in internal energy of the reaction. So we're now going to use another formula to solve this. So first of all, whenever you see a question where you're given the change in enthalpy of reaction and then you're not given the change in internal energy, or you're given the change in internal energy of reaction and then you're not given the change in enthalpy of reaction, you're going to use this general formula here, which says change in enthalpy of reaction minus change in internal energy of reaction is equal to change in the number of gas molecules RT. That's basically what this is. Of course, you already know we have determined the change in enthalpy, okay, of a reaction, and we have that to be negative 174.47 kilojoule per mole. So if we can get this side of the equation, okay, now we have to find this side of the equation in order for us to find this one here, which is a change in internal energy of reaction. So we have change in the number of gas molecules, RT. Well, before we can do this, we have to first of all determine what is a change in the number of gas molecules. To do this, you have to go back to the equation. We're given a particular equation and we're going to use this to solve this. To do that, first of all, before I go ahead and solve it, let me explain to you what's going to happen here. Okay, the change in the number of gas molecules is just going to be the number of gas molecules for the final state or for the product side, okay? So final state of reaction is basically the product, the state of the product, as well as the number of gas molecules in the initial phase for the reactants. So that's just basically what's going to happen. So you're going to pick the number of gas molecules for the product minus the number of gas molecules for the reactant. So the number of gas molecules for the product is just simply one, C2H4. So that's just basically one gas molecule. So that we're just going to have that here. So one, okay, 1 minus change in the number of gas molecules for reactants. That's going to be, we have one molecule of C2H2 as well as one molecule of H2 gas. So we have 2 here. So basically change in the number of gas molecules is going to be -1. So yeah, that's it. So we're now just going to put this information here. So we have -1 times R, which is the common gas constant. So that's 8.3145 joule per mole Kelvin, times temperature, which is just, we're given that at the beginning of the class. So that's 298 kelvins. So times 298 kelvins. So yeah, let's cancel out the Kelvin, cancel out the Kelvin. So changing NGRT becomes -1 times 8.3145 times 298 kelvins, and that's going to give us -2477.72 joules per mole. Or we can just write it in kilojoules per mole, since, of course, our change in enthalpy of reaction is in kilojoules per mole, and we're going to be using it soon. So it's best for you to keep the information in kilojoules per mole. So that's going to be -2.477772 kilojoule per mole. So going back to our math, we know that changing enthalpy of reaction is going to be, sorry. So we know that rewriting this in terms of changing internal energy of reaction. So we know changing internal energy of reaction is going to be changing enthalpy of reaction, okay, minus change in number of gas molecules, RT. So yeah, so we can put change in internal energy of reaction to be -174.47 kilojoules per mole. Okay, minus what we've gotten here, which is -2. Don't forget the other negative. So the information has negative and the formula has negative. So that would be -2.47772 kilojoule per mole. So what we end up with, change in internal energy of reaction is going to be -174.47 kilojoule per mole plus 2.4777 kilojoule per mole. So change in internal energy of reaction is going to be equal -171.9923 kilojoule per mole. And of course, we can do this in 2 sig figs to get change in internal energy of reaction to be negative 171.99 kilojoule per mole. Yeah, so I wish you guys all the very best. This is basically the answer to the question. If you have any questions, please put it for me in the comment section, and I'm going to try my possible best to help you. And you have any concerns as you're doing this class, make sure you put it in the comment section, as well as any suggestions you may have. If you're trying to be the best version of yourself with relation to academia, and you want to be the best student, or you want to be the best person you can be, basically fulfilling your potential and being successful in all your courses, especially the courses relating to STEM, make sure you email me at yourhabitutoring@gmail.com. I am a personal tutor as well as mentor and educator for students who are striving to succeed in their academic life. So, yeah, make sure you email me. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.